just to list the improvements with WEP. I will not be discussing each and every improvement in this video. I'll be creating more videos to know how exactly the encryption is taking place. Just to list them, there is a message integrity code, MIC, which is a integrity code so that the tampering will not be that easy. Then IV selection and reuse is important thing. So IV reused as a replay counter. IV is just not initialization vector, but it is also reused as a replay counter. Same IV will never happen again. Per packet key mixing is used. Then again there is a increase in IV size. In WEP WEP the IV was just 3 bytes. Now in TKIP it is increased to 6 bytes. There is a key management added in protocol algorithm itself, so that the mechanism of key distribution and change in key can be easily incorporated. Before going into details about the encryption algorithm, I think it is very important to see after encryption how our WPA-TKIP frame will look like. So initially it will have a 802.11 MAC header. MAC header is generally 24 bytes, but if your transmitter and receiver support QoS, the accordingly fields will increase. If it is 11N, then some more fields will be increased. Then it will be a IV or key ID, 4 octets will be present. Then extended IV of another 4 octets will be present. Then actual data will be present. Actual data will be more than 1 octets, of course. Then MIC or message integrity check value will be present. It will be 8 octets. Then ICV or integrity check vector will be present. This ICV is similar to WEP thing. And then of course FCS frame checksum. This is just a checksum 4 octet. Now in WEP the packet was very much similar. It was having 802.11 header, of course. The IV or key ID field was exactly same. It was again 4 octets in WEP as well. Extended IV field was not present, it was absent. Data was present. MIC was absent. The message integrity code was just ICV, which was weak. FCS was of course present. Now the IV key ID field, which is 4 octet, contains the TSC1. Now in WEP the IV is called TKIP sequence counter, because IV is used for initialization vector as well as it is used, or the function is overloaded with the sequence counting. So it is generally called as TKIP sequence counter, TSC. So this first 4 octets contains TSC0 here as a third octet. First octet is TSC1, second octet is WEP seed, and third octet is key ID. Now what exactly this key ID contains I'll be explaining in next slide. Just bear with me. And in extended IV the next octets of the TSC or IV are present. TKIP sequence counter 2, 3, 4 and 5 respectively. Now what exactly is present as a key ID? Just wait for a while. TKIP frame fields, initialization vector IV, TKIP sequence counter 0 and 1. In this first TKIP sequence counter IV key ID field, TKIP sequence counter 0 and 1 are present. Then key ID, the LSB or the 7th bit contains the key index, 6th field again contains the key index. What are these key indexes we will be seeing in successive videos. The 5th bit is extended IV. Now we must be able to distinguish between TKIP packets and WEP packets. Other than this extended IV field, there is no check or there is no indication in MAC header that this is a WEP packet or this is a WPA-TKIP packet. So if this bit is particularly 1, you can surely say this is a non-WEP packet, or there is extended IV present in this packet, and all other lower order bits 0 to 4 are as of now reserved. So in these key ID field, this 5th bit is very important bit, and then of course extended IV will be present. The TKIP sequence counter 2 to 5 bits will be present. After TKIP sequence counted extended IV field comes the data, and at the end of data the MIC or message integrity check is present, this MIC is computed over entire payload of the MSDU. While calculating MIC, not only payload is taken into consideration, but also the source and destination MAC addresses are taken into consideration, so that the forgery or the identity theft can be also taken into account. It is added at the end of last MPDU fragment of the MSDU. So if there is a fragmentation of the packets, the MIC or message integrity check will be present only in the last fragmented packet. So MIC is not added in MAC protocol data unit, but it is added in MAC service data unit. Then the ICV component, ICV checksum is calculated over, of course, the clear text payload, and FCS or frame checksum. Frame checksum is 32-bit CRC calculated over all fields of MPDU. Of course, FCS has to be present in every fragment. That's it for this video. I'll be talking more about TKIP, how exactly encryption takes place, and at the end the problems with TKIP and a recently introduced attack on TKIP in successive videos. Thank you.